Hello everyone, welcome to Hope's class. Today we will look at the derivative rules. We have talked about the power rules for derivative in the last video. In this video, we will look at more derivative rules. We have the constant rules, constant multiple rules, sum rules, and the difference rules are showing up in the table. You can pause and look at it if you need to. We will go through all these rules. Okay, first example, constant rules. If f(x) is a constant, determine its derivative. We will start with the definition, then substitute f(x plus h) is c, and f(x) is c into the equations. Simplify the numerator, gives you the answer of 0. Use the limit properties, the final answer of f'(x) is 0. Conclusion, if the function of f(x) is c, then its derivative is 0. Okay, second example, constant multiple rules. If f(x) is c times gx, for any constant c, determine the derivative for f(x). We will start with the definition, then substitute f(x plus h) is c times gx plus h, and f(x) is c times gx into the equation. Factor out the constant c, since it's independent of h. Move it outside of the limit. Use the definition of derivative backward. Solve the answer is c times g prime x. Conclusion, if f(x) is c times gx, then f prime x is c times g prime x. Okay, third example, sum rules. If function f(x) and gx are differentiable, and the tx it is f(x) plus gx, determine the derivative of tx. Start with the definition. Substitute the tx plus h and the tx into the equations. Rearrange the numerator. Put the f(x) and gx into the different square bracket. Split the numerator and the limit using the limit properties we talked about before. The last step is to apply the definition of derivative backward and solve the final answer. Conclusion, if tx it is f(x) plus gx, then t prime x it is f prime plus g prime. Okay, last example, difference rules. If function f(x) and gx are differentiable, and the tx it is f(x) minus gx, determine the derivative for tx. Start with the definition, then substitute the tx plus h and the tx into the equations. Rearrange the numerator and put f(x) and gx in different square bracket. Split the numerator and the limit using the limit properties we discussed before. The last step is to apply the definition of derivative backward and solve the final answer. Conclusion, if tx it is f(x) minus gx, then t prime x it is f prime x minus g prime x. Thank you. For more information, please search Toronto Teacher Hope in YouTube.